Buddy. We took a week off. Been pretty busy, so kind of got things to catch up on. Um, a lot going on lately. So let's do the last piece of graphing trig functions. Now, I'm actually going to give you a preview of the 4 problems we're going to do together, so you can kind of understand where we're going with it. If you probably might have already figured it out based on the A, B, C, and D parameters of sine and cosine functions. Now, these also apply to tangent, but tangent, cosecant, secant, and cotangent, those are all strange animals. Those really don't model the kind of basic physics that you would see like with light and sound and spring action, stuff like that. So we're going to focus on sine and cosine and pre-calc. And we're going to graph just the basics of tangent and the other 3 reciprocal trig functions. So I'm going to show you what they look like, and I want you to be able to recognize that graph, but we're not going to be shifting them around a lot. We're either going to move them to the right or left, up and down. We're not going to be, changing the periods or amplitudes of them because they're very strange and pretty rare. So you can see here now with a phase shift is now we're actually playing with the C parameter. So my A is 1, my B is 1, my D is actually 0, so I'm not going up or down. And you might want to review A, B, and D from previous lessons before we jump into this. But essentially, this guy is the right and left motion. Okay, a phase shift is pretty much called a phase shift because that's what they use in electricity. A phase shift is basically they need a phase shift for, let's say you own a factory and the factory needs a lot of power. And so what they can do is they can actually phase shift an electrical current so that they can get triple the amount of electricity through the same wires, because they take one electrical current and then they take another, but the next one is phase shifted. I forget, like 60 degrees or something, and then they phase shift a third one 60 degrees so that none of them are actually on top of each other. All 3 currents can flow at the same time through the same wire, which is pretty awesome. But 3 phase shifts is, or the triple phase electricity, that's the limit. Like, you can't do a 4th phase, because what you would do is you'd get overlap and you would start having surges, or at least that's what I think. All right, so phase shift is pretty important when you're dealing with electricity. So they call them phase shift because that's its most common use. Anyways, we're going to take this cosine shape, right? And we're going to actually shift him plus pi over 4. Okay. Now you probably remember. Now, when you do this, I'm not going to do this in marker. I'm going to use a pencil with an eraser. It's always going to be next to me when I do these trig functions, because you can always make a simple mistake. All right, because we're going to go with cosine, then we're going to shift sine. But then notice here, I'm going to actually have 3 more parameters. Now, I'm not going to do a period shift here. Okay, that B, okay, he's still 1, but I do have an amplitude change, I have a phase shift, and I have a vertical change. And I'm going to do the same thing with sine. So we're going to do the same parameters, but we're going to do sine so you can kind of see what it looks like. What is the difference between a sine and a cosine? And hopefully you remember, it's not much. All right, it's not much. All right, not much in its basic shape. So here's cosine, and we know that cosine, okay, the cosine actually starts, and since I don't have an amplitude change, I'm actually going to make 1. I'm going to make 1 right here in the middle. All right, and I'm going to put -1 right there. Now, cosine actually starts at the peak of his wave, okay, the peak, and then he actually, right here in the middle is where he reaches its minimum, and then at the very end of his cycle, he goes back up to his peak again. Let me think I got more lead here. Okay. All right. So right in the middle is where he hits 0. Right in the middle is where he hits 0. So here's normal cosine. Okay. That's normal. But I need to take the whole thing and I'm going to shift him pi over 4. Now, which direction? Hopefully your intuition and your memory, prior knowledge actually serves you well. And remember that when you have parentheses, whatever the sign is on the inside, its effects on the actual function forces it to go not to the right in what we consider the positive direction, but actually forces it left. Okay, so if you see a plus sign right there, that means that's a left transformation. And if you see a negative sign in the middle, that is a transformation to the right. All right. All right. So with cosine, we're going to go to the right, pi over 4. Now, let's investigate and see where is pi over 4. Like, what is that distance? Now, it looks like every 3 units I have a pi over 2. And I know that pi over 4 is actually half of pi over 2. Pi over 4 is half of a half. So I'm going to go right in the middle here. That's actually pi over 4. All right, now what that means then is I'm going to take all of these 3 other points and I'm going to pull them 1.5 units because that is a pi over 4 length on the x-axis. So I've got this point here. Well, let's count. I got 1, 2, 3, 4, 5 major points that I'm going to focus on, and those are the ones that I'm going to take every single one, and I'm going to move them to the left pi over 4. And again, our length here on this graph is 1.5 units. So this guy goes, let's see, 1, there's 2, so 1.5. So he will go here. This guy will go to here. Okay, and I'm actually going to change its color now. You actually should still keep it in pencil. Okay, this guy's going to go 1.5 this way. This guy goes 1.5 that way, and this guy goes 1.5 that way. So notice, I'm going to draw arrows actually for this one. Each one of those went to the right, pi over 4 distance. Okay, and so now I'm going to go ahead, and since there's no other shifts, I'm going to go ahead and graph this guy. Whoops. Okay, so the whole wave has basically shifted pi over 4. The original wave would have looked like this. Okay, so you can kind of see it's like a three-dimensional ribbon there, you know, some kind of shape like that. But the blue line is actually our answer. All right, so now that's it. There's no other transformations. We'll worry, you know, these two are coming down the pike. Now for sine, I'm going to graph sine, stop the video, do the last two in the next. So for sine, he has a different pattern. What happened is that with sine, we don't start at the peak and go like that. That's cosine. We actually start in the middle and do that. So that's the sine wave. And we're going to shift him to the right, pi over 2. So I'm going to draw the parent function of sine. And remember that we'll go 1, -1. Okay, and then we're going to go 0. And I know that in the middle he goes to 0, and then at the very end he goes to 0 because that's his pattern. Okay, and then I know in the middle here at pi over 2 he hits his peak, and at 3 pi over 2 he hits his minimum. So I'm going to graph this guy. Okay, I'm going to graph him. He's just my baseline. What I'm going to do is I'm going to shift everything to the right, pi over 2. Now how many units is pi over 2? Well, looks like pi over 2 is actually labeled, and from 0 he's 1, 2, 3. He's 3 units. So everything is going to move over to the right, pi over 2. So now this point moves all the way over to here. This point moves 3 units. Now be careful, you know, just the pencil is moving to the red, okay? So this guy is not him. That's not him. This guy is actually being shifted here. This guy's being shifted here, and this guy's being shifted over there. And so if I were to go backwards, I would actually be going here. Okay, so you can kind of see here. All right, that the sine wave has actually moved over pi over 2 units to the right. Now, if you were to just look at the red line, you can kind of see that this is the same thing as cosine, but it's been flipped. So believe it or not, this is the same as negative cosine of theta. So if you phase shift sine, you can get it to be a cosine function. Cosine and sine are just phase shifts of each other. All right. So if you want a sine, you can take a cosine, phase shift him so that he lines up with a sine wave because they're complementary to each other. All right. So this is true. Okay, now that's kind of more important for when we do trig identities. I don't think we're going to get to them this year, unfortunately. It's usually the thing that we end up the year with. But you know, this is it's important to know that you can always manipulate trig functions to get something simpler. Okay, all right. So this and this are identical. All right, I'm going to stop there. And then in the last video, we will do the last two.